Okay, so let's take a look at example 3 here. Finding theoretical probability. Your friend has 4 sweatshirts. One sweatshirt's green, one is white, and 2 are blue. You forgot your sweatshirt, so your friend is going to bring you one, as well as one for himself. What is the probability that your friend will bring 2 blue sweatshirts? Okay, so let's see here. So we've got one green, one white, 2 blue. So let's think of the sample space here. The sample space is that perhaps you get a green and a blue, a white and a blue and a blue, or a green and a white. Now notice that order doesn't matter here, because bringing you a blue and a green sweatshirt is the same thing as bringing you a green and a blue sweatshirt. So it looks like there are 1, 2, 3, 4 possibilities, and only one of them involves 2 blue sweatshirts. So the probability, which we write P of blue, blue, blue sweatshirt, is equal to the one success, the one positive outcome, the one that we're trying to measure, divided by the 4 possibilities. So 1/4, which is 0.25, which is 25%. That's how I would answer that question. At a school dance, the parents sell pizza slices. The table shows the number of pizza slices that are available. A student chooses a slice at random. What's the probability that the student chooses thin crust slice with pepperoni? I'm assuming that these numbers mean how many slices there are. Like there's 34 thin crust pepperoni, 36 thin crust cheese, 8 thick crust pepperoni, and 12 thick crust cheese. I know I don't know why they only got 8 of the thick crust pepperoni, because that's obviously the best one. But so the question is, how many positive outcomes are there? If this student is the very first person to show up, so thin crust slice with pepperoni, there are 34 pizzas that match that bill. Out of how many pizza slices altogether was the 34 that we're interested in? The 36 cheese thin crust, gross. The 8 thick crust pepperoni, yes please, and 12 thick crust cheese, which if you got to do it, you got to do it. So we're going to add all those up. 34 plus 36 plus 8 plus 12, 90. I would rather not write that in highlighter. I still don't want to write that in highlighter. So that's 34 out of 90, which reduces to 17 out of 45. So there's a 17 over 45 probability, which, is that a 17 out of 45? That's not too bad. 0.37 repeating probability, which I was going to go ahead and say 37.7 repeating percent. I can give it to you exact like that. That's the probability that they get the, I'm going to say the second best type of pizza that you can get there. Okay, so let's say that event A is rolling a 6-sided die, and event B is flipping a coin once. Ben thinks the probability of getting an even number from the die roll along with the heads on the coin flip is more likely to happen than getting a prime number from the die roll along with the tails on the coin flip. Cameron says the probability is the same. So let's make a sample space of the experiment. So you might get a 1 and a head, a 1 and a tail, a 2 and a head, a 2 and a tail, a 3 and a head, a 3 and a tail, a 4 and a head, a 4 and a tail, a 5 and a head, a 5 and a tail, a 6 and a head, or a 6 and a tail. Those are all the possibilities here. So who's correct? Well, let's first check what Ben thinks. Ben thinks even number with the heads is more likely than prime number with a tails. So let's look at each of those. So even with a heads is going to be no, because it's odd in a heads. No, that's odd in a tails. Yes, that's an even in a heads. No, that's even in a tails. No, that's odd in a heads, odd in a tails, even in a head. Even in a tails, odd in a head, odd in a tails, even in a head, odd in a tails. So the probability, I'm just going to go ahead and put this down here. Probability of an even number combined with a heads is equal to 1, 2, 3 out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possibilities, which reduces to 1/4, which is 0.25, which is 25%. It looks a little worse than that in that picture there, but what are you going to do? Now, what about getting a prime number with a tails? Let's go ahead and highlight those in green. So 1 in a head, well, 1 is neither prime nor a composite. 1's a different kind of number. 1 in a tails, so neither of those work. 2 in a head, that's a prime number and a head, but I need prime number and a tails. Prime and a head, prime and a tails. Composite, composite, prime and a head, prime and a tails, composite, composite. So again, take a look at that. The probability of getting a prime number along with the tails is equal to 1, 2, 3 out of the 12 possibilities, which is also 1/4, which is also 0.25, which is also 25%. So Cameron, even-headed fellow that he is correct. The events are equally likely. Very good. Oh, and that's it. Well, that makes life easy. That's it. That's all I got for you on this lesson here. I hope you learned a whole bunch. If you have any questions, send a message to your instructor. This is, that's right. Oh, yeah, there was one more thing I had to say. Sorry. Go back to that first page of your notes here. So event A is a subset of all the letters. What letters are in this subset? I thought this is example 2, part C. I think I misread that, and it's saying what letters are in the subset of H and O and P, and it's H and O and P. I actually prefer this explanation I gave you anyway, because it's saying that hop is a proper subset of all the letters that are in here, all the letters that we know. Anyway, that's all I've got for you. This is Mr. P signing off, and I hope you have a wonderful rest of your day.